Hello everyone! Today we will have a new lesson about types and components of the motherboard. The motherboard is the main component of any branded or assembled PC or laptop, tablet, or mobile phone. Now, you must be curious why it is called the motherboard. The motherboard is a printed circuit board which acts as the main platform for communication between all other components of a system. All the other computer parts are either directly installed or connected to various motherboard components, and all the data is transferred between them through the motherboard. There are types of motherboard form factors. These are standard ATX, Micro-ATX, Mini-ITX, Nano-ITX, and Pico-ITX. Let us first discuss about the form factor ATX or Advanced Technology Extended. The standard ATX form factor is the most popular because it has every feature which can fulfill almost every requirement, be it for a gaming or productivity. An ATX motherboard is larger than a Micro-ATX and smaller than an E-ATX motherboard. A modern ATX motherboard looks like as follows. An ATX motherboard packs in tons of features with a lot of upgradability that is enough for several years depending on the user's needs. More ports and slots are available as compared to Mini-ITX and Micro-ATX, but it costs more than the two form factors mentioned above. General dimensions of an ATX motherboard are 12 by 9.6 inches or 30.5 by 24.4 centimeters. Almost every mid-tower can fit in an ATX motherboard without any problem. Why an ATX motherboard is used? An ATX motherboard provides almost every feature which an enthusiast may need, including overclocking, a lot of storage support, high-end CPUs, more memory, better cooling, and so on. An ATX form factor motherboard is good for those who don't have any space problem and have a good-sized CPU cabinet that takes more space than a Micro-ATX or Mini-ITX case. Also, ATX motherboards look better in design and fill up the interior of a chassis. How about the features? One of the most advantages of an ATX motherboard is that it provides several PCI slots and at least 4 times DIMM slots that can support a lot of memory. Modern motherboards support more than 32 gigs of RAM easily. These motherboards may or may not have an unlocked chipset, but those having unlocked chipsets have very good VRMs with efficient heatsinks for stable overclocking. Next, the Micro-ATX. A Micro-ATX motherboard is bigger than the ITX motherboard and smaller than an ATX motherboard. Generally, it has dimensions as 24.4 by 24.4 centimeters or 9.6 by 9.6 inches. But some motherboards may have dimensions as 9.6 by 8.1 inches or 24.4 by 20.6 centimeters depending upon the slots and ports they come with. A modern mid-high-end Micro-ATX motherboard looks like the following. Why a Micro-ATX motherboard is used? A Micro-ATX motherboard serves both the purpose of good features and compactness. As it is bigger than an ITX motherboard, it supports more slots and ports while remaining smaller than a full ATX motherboard. The size also varies, making it a flexible form factor. The features of Micro-ATX are depending upon the dimensions, the number of PCI slots and memory slots differs in quantity. A Micro-ATX board can either have 2 times DIMM slots or 4 times DIMM slots, which makes it wider or narrower. Similarly, a particular Micro-ATX board can have only 1 time PCI-X 16 slot, but the other one can have up to 3 times PCI-X 16 slots. These boards come in a variety of features, ranging from budget to high-end, having great VRM section, big heatsinks, modern headers, and more storage facilities. Next, the Mini-ITX. From the name itself, you can guess the size. Generally, its smallest form factor which is used in PC, people use for day-to-day purpose. Take a look at how a modern Mini-ITX motherboard looks. This is a very small motherboard which has limited features but not necessarily the minimum. A Mini-ITX motherboard measures around 17 by 17 centimeters or 6.7 by 6.7 inches in dimensions. Computer cases which support Mini-ITX motherboards will have the screw holes at the exact same position no matter which case you buy, and these dimensions are fixed. Why Mini-ITX motherboard is used? Mini-ITX motherboard is used to save as much as space possible, providing all the basic features a bigger board can provide. Some people prefer building a PC in a Mini-ITX case, which is also much smaller than an ATX case and provides a compact solution to those who don't have any space for their PCs. In terms of features, a modern Mini-ITX motherboard supports the same size socket as a bigger board, but some ports and slots are decreased in quantity. There will be never more than 1 time PCI-X 16 slot on a Mini-ITX motherboard and never more than 2 times DIMM slots for memory. Almost every ITX board has only 4 times SATA ports for storage and a few fan headers, but features like overclocking may vary. Basic budget ITX motherboards don't have unlocked chipsets, but expensive one may have unlocked chipsets which are used for overclocking the processors. How about the Nano ITX? The Nano ITX is another type of motherboard form factor that measures 4.7 by 4.7 inches. Nano ITX are fully integrated boards designed to consume very low power. This type of motherboard can be used in many applications, but it was specially designed for smart entertainment like PBRs, media centers, smart TVs, in-vehicle devices, and more. Pico-ITX. The Pico-ITX is the smallest type of motherboard form factor in this list. Its measurements are 3.9 by 2.8 inches, and it is 75% smaller than the Mini-ITX. This motherboard was designed and developed by VIA to open up innovation for smaller and smaller IoT devices. The Pico ITX with an 86 base platform and low power consumption board is a great choice for embedded systems applications such as industrial automation, in-vehicle computers, digital signage, and more. Here is the brief comparison of the motherboard form factors. The form factors, manufacturer and date, dimensions, and the applications. Let's proceed to the other sample images of motherboard. The Mini-ITX Motherboard, the Micro-ATX Motherboard, ATX Motherboard, E-ATX Motherboard, AT Motherboard, motherboard for P1, P2 processors, Pentium 4 motherboard. And now, let's talk about the components of a modern motherboard. A motherboard consists of various components which have their own role to play in the functioning of a computer. Let us discuss various motherboard components and know their definition and role. CPU socket. A CPU socket is where a processor is installed. Currently, there are two major manufacturers of processors, Intel and AMD, which produce processors that are installed on different sockets. They are not interchangeable and their sockets are different from each other. A CPU socket comprises of several hundred pins that get in direct contact with the processor chip, or a socket may have several hundred pinholes as in the case of latest AMD AM4 socket. Both Intel and AMD have released various sockets in the past decades that support a particular generation or generations of processors. VRM. VRM stands for Voltage Regulator Module and is responsible for regulating the voltage from the power supply for correct voltage to the CPU. A power supply has a plus 12 VDC EFPS power connector that is responsible for supplying the voltage to the VRM, and the VRM converts the 12V into a voltage of somewhere between 1.1 voltage to 1.4 voltage, which depends on various factors. A VRM consists of three components: capacitors, chokes, and MOSFETs, which are there to ensure that the power supply is stable and controlled. Next, the DIMM slots. DIMM or Dual Inline Memory Module slots are used for installing RAM sticks which store data temporarily and are different from storage drives, which can store data permanently even after the power supply is cut off. DIMM slots quantity vary from board to board. A modern motherboard with any of the four form factors can consist of DIMM slots ranging from 2 to 8. PCI or expansion slots. Expansion or PCI or peripheral component interconnect slots are for connecting peripherals directly to the board using the PCI slots that differ in size and capability. Most common PCI slots today are PCIe times 1 and PCIe times 16. Older motherboards used to have AGP slots too, that were used for installing a video card, which are now replaced by PCIe times 16 slots. SATA. SATA, which stands for Serial Advanced Technology Attachment, is an interface which connects a storage device like a hard drive or a solid-state drive to the motherboard. Unlike the other components, a SATA hardware or hard drive or SSD is connected via a SATA cable which has 7 pins. M.2 M.2 is amongst the latest additions to the motherboard, which serves as an interface to connect SSDs, Wi-Fi, Bluetooth, and so on. As buses such as PCI, SATA, and USB get exposed to it. An NVMe SSD connected through the M.2 connector doesn't get bottlenecked unlike through the SATA port, as it gets 4 PCI lanes to transfer data, resulting in speeds that are several times faster than the SATA drives. Most of the Intel and AMD motherboards nowadays feature at least one M.2 slot. Next, the audio. Every motherboard has a dedicated audio section near the audio jacks at the I/O. It can generally be identified by PCB circuit line inside, which there are several capacitors. High-end motherboards have more components in the audio section for crystal clear sound. CMOS Battery. CMOS battery is a non-volatile RAM which is present in every motherboard and can be identified easily as it is silver and round in shape. This battery is responsible for storing the hardware information such as the specs of CPU, RAM, disk drives, graphic cards, and so on, in the BIOS, and is also responsible for the correct time and date. Headers. Headers are the pin connectors which are used for connecting peripherals to the motherboard. Components like chassis pans, CPU pans, front panel audio, and USB ports, RGB devices, and so on, are connected to the motherboard through these headers. Each of these headers has a different pin configuration and work on a particular voltage. Next, the power connectors. A motherboard is powered through power connectors, and there are different power connectors for different components. Some of the components don't need additional power connectors on the motherboard, such as RAM, storage drives, and low-profile graphics cards, which draw the power from the slots. There are two main power connectors, ATX and EPS. Their pin configuration varies from board to board. While ATX power connector is responsible to deliver the power to different sections of the motherboard, the EPS power connector is solely dedicated to supply the power to the VRM. And last, the input or output ports. Every motherboard has an input and output section at the rear where several ports are present to connect the peripherals. Ports like USB, PS2, HDMI, VGA, LAN, and audio jacks are available here to connect the devices. That's all the learnings about the types and components of the motherboard. Thank you for watching and have a nice day.